Look at this problem in hydrocarbon. Pent 1-ene. Pent 1-ene with hydrochloric acid gives. Actually, 4 options are given, but we can directly write the equation and write the product. Pent 1-ene. First of all, you should know to write the molecular formula from the nomenclature, from the name. So pent 1-ene means 5 carbons. 1, 2, 3, 4, 5. And in the first carbon, an unsaturation is found. So CH2, H, CH2, CH2, CH3. So when this organic compound is reacting with the hydrochloric acid, what will be the product formed? So this is addition reaction. Across the double bond, the H and the Cl are going to be added. According to Markovnikov's rule, when HCl is undergoing heterolytic division, it forms H plus and Cl minus. According to Markovnikov's rule, the H plus will go to the carbon which has more number of hydrogen, and the negative part will go to that carbon which has less number of hydrogen. Therefore, the product formed in this reaction is CH3, CH2, CH2, CH, CH3, and chlorine is substituted here, or chlorine is added here. So now the name of this compound is, you have to number the carbon atom so that the chlorine gets the least number, 3, 4, 5. Therefore, the name of this product is 2-chloropentane. 2-chloropentane. So when 1-pentene reacts with hydrochloric acid, 2-chloropentane is formed. This question is very important. Say some 4 reactions are given. I'm going to write all the 4 reactions. And you are asked to identify the wrong one. See the first reaction, A, CH3, CH, double bond CH2. When it reacts with hydrogen bromide in presence of hydrogen peroxide, CH3, CH2, CH2, Br is formed. Reaction B, CH3, CH, double bond CH2. When HCl is added in the presence of hydrogen peroxide, CH3, CH2, CH2, Cl. And the third reaction is CH3, CH, double bond CH2. HBr is added. CH3, CH, CH3, Br here. Option D, CH3, CH double bond CH2, HCl, CH3, CH, Cl, CH3. Now look at these reactions. In C and D, this addition reaction, addition of H and Br in the double bond. So according to Markovnikov's rule, the H will go to this H2 and Br minus will go to this C. So the product formed is CH3, CHBr, CH3. It is correct. And similarly for the reaction D, the positive species will go to that carbon with more number of hydrogen and the negative will go to that carbon with less number of hydrogen, and this is also correct. But look at here. So when the same reaction is conducted in the presence of peroxides, peroxide effect, anti-Markovnikov's rule will be followed. So according to anti-Markovnikov's addition, the positive H plus will go to that carbon with a less number of hydrogen, and the negative part will go to that carbon with more number of hydrogen. Therefore, this product is also correct, and accordingly, this is also appearing to be correct. But a very important thing you should note down here is the presence of peroxide will not affect addition of HCl. So whether peroxide is present or not, it will not affect the addition of HCl across the double bond. So here the product formed will be this. This is the product formed here also, because the presence of peroxide will never affect the addition of HCl in the double bond. Now, number of reactions are given. I'm going to write a number of reactions, and you are asked to find out the name, and one particular name is wrongly written. You have to identify. A, CH3, C, CH3, double bond CH2. Watch closely. HBr is added. This reaction is called, or the intermediate that is appearing in this reaction is carbocation. Carbocation. I suppose you know what is carbocation. And the second reaction is CH3, C, CH3, double bond CH2 plus HBr in the presence of peroxide. This reaction takes place through free radical intermediate. Free radical intermediate. And the reaction C, C double bond C plus any halogen. What is given in the question is this undergoes electrophilic substitution. Electrophilic substitution. And D, C double bond C, O3. This reaction goes through ozonide formation. Now you have to identify the wrong one. The wrong one is, this is correct. The reaction is going through carbocation intermediate. And the reaction B is also correct. The reaction goes through free radical intermediate. But the third one is, it is not substitution. Substitution means something has to be taken out. And in the place of that, some other thing has to be kept. So this is electrophilic, no doubt about it, because the pi electrons or the excess electrons are present in between these two carbons. They attract electrophiles, and the electrophiles come here and react. But it is not a substitution reaction. It is electrophilic addition reaction. The electrophile is getting added. This is ozonide, that is also correct. Therefore, the wrong one is this. So you should understand, this is not a substitution. This is addition. Suppose if this reaction is taking place on a benzene ring. Benzene ring is there. If a hydrogen is replaced by some other electrophile, then it is called electrophilic substitution, because this hydrogen here is replaced by an electrophile. It is called electrophilic substitution, but not in this case. Because during substitution, the bonds will not change. But here, the double bond will become single bond. That means it is an addition reaction. So answer C is wrong, because the double bond is becoming single bond after the addition of chlorine or a halogen. But the halogen is coming towards this organic compound because of the excess electrons present. Therefore, it is not electrophilic substitution. It is electrophilic addition. I slowly read the question. You can take it down. A compound X decolorizes bromine water. It decolorizes bromine water and reacts slowly with sulfuric acid. Reacts slowly with sulfuric acid to give an addition product. It gives an addition product. So every small piece of information should be analyzed for the investigation. And X, it also reacts with HBr to form the compound Y. And this Y reacts with NaOH to form the product Z. And the Z on oxidation, gives hexane 3O. So I read the question again. A compound X decolorizes bromine water and reacts slowly with the concentrated sulfuric acid to give an addition product. X reacts with the hydrogen bromide to give Y. Y reacts with the sodium hydroxide to give Z. On oxidation, Z gives hexane 3O. Identify X, Y, Z. See, first of all, you have to understand it is decolorizing bromine water means number one, X is an unsaturated compound. Unsaturated compound. And the final answer is hexane 3-one. Therefore, this unsaturated compound has to have 6 carbon atoms. According to the question, it's supposed to have 6 carbon atoms. But in the 6 carbon atoms, it is an unsaturated compound. So we have to identify where the unsaturation is. Unsaturation supposed to be in the 3rd carbon because in the final product 3-one is formed. Therefore, something is happening in the 3rd carbon. Therefore, let me put an unsaturation here between 2 and 3. And then this is CH3. This is CH. 1, 2, 3, 4. This is C, CH, CH2, CH3. Now let me proceed. When this reacts with sulfuric acid, it gives a very slow reaction, forming CH3, CH2, one, two, three, four, 5. 1 carbon we left. 1, 2, 3, 4. This side, CH2, CH3. So, CH2, CH, HSO4, CH2, CH3. So this is a slow reaction. So now, with NaOH, so bromine substitution takes place here. CH3, CH2, CH2, CH, bromine gets substituted here, CH2, CH3. With NaOH, you know, when alkyl bromides react with NaOH, that gives alcohol. CH3, CH2, CH2. In the place of bromine, OH group is getting attached. CH2, CH3. So this alcohol on oxidation is a secondary alcohol. So primary alcohol on oxidation will give aldehyde. Secondary alcohol on oxidation gives ketone, CH3, CH2, CH2, C double bond O, CH2, CH3, which is 1, 2, 3, 4, 5, 6. So this is hexane 3-one. So your compound X is hexane 3-ene, and your compound Y is 3-bromohexane, and the compound Z is 3-hexanol or hexane 3-ol, 3-hexanol.